In the videos that have led up to now, we've been looking at several different means of storing lists of objects. So we've looked at arrays, at collections of objects, and then also generic collections. But there's been one task that's plagued us no matter which example that we've looked at, and that's how to keep around a list of objects that are of potentially different types, different classes, but still call the print method on that given object regardless of what class it belongs to. So by the way, what we're really looking to do here is to implement some form of polymorphism in our code. Polymorphism is the ability for code to act like many different things, but still be treated the same. If you think about the array list, we were able to put both an automobile object and a book object into the same array list. The reason is that both inherit from the same base class, system.object. Because as we said before, all reference types, like our custom types, inherit from the system.object base class. Now, truth be told, there's a bit of magic going on under the hood, but on the surface, we're seeing some polymorphic behavior here, the ability to add, no matter what it is, to an array list. Polymorphism is the third tenet of object-oriented programming. So do you remember the first two? Encapsulation, inheritance, and now polymorphism. Okay? So the print method that we've been looking to execute on all of our objects, regardless of what class they are, is really an example that's just the tip of the iceberg. Much later, when we begin to learn more about architecting our entire applications, polymorphism starts to play a bigger and bigger role. So we're just going to cover the ABCs right now before we start reading or writing a novel. Okay. So back to the question at hand. How can we treat a list of objects polymorphically? How can we call the print method on a custom type regardless of the type? Well, there's actually three different ways that we're going to look to do that over the next couple of videos. Okay, the first solution draws from our inheritance discussions from yesterday. So let's take a look at a quick example. You can see here that I have a project called Polymorphism via Inheritance. So if you take a look at what we've done here, we've introduced another type called product. And so the product class defines a product ID and then also defines a virtual method called print. Remember what the word virtual means? It means if there's a more specific implementation of the method, in this case print, on a derived class, then use that instead of the one that's defined here in the product method in the base class, right? All right, so then if we take a look at both our program class, both our automobile class and our book class, we're going to see that both of these inherit from product. In addition to inheriting the product ID, the automobile class specializes in so much that it adds additional auto properties, right? Make, model, year, miles, and exterior color. Furthermore, it overrides the base implementation of print so that it can create a more friendly experience that's specific to an automobile. It has an implementation that's specific to an automobile. You wouldn't write this about just any product, not just any product has a year, a make, a model, an exterior color, and miles. It wouldn't print out like this as a silly example. Okay, same is true with the book.cs. Here we can see we've extended the product class by adding additional properties and by overriding the print method to display ISBN, the title in a certain format, and so on. Again, specializing that product class. So here we go. Let's go back to the program.cs. Here I'm going to create one automobile and one book, and I'm going to add them both to the inventory. Now notice this, that here I am declaring my inventory as a list of product. How is that possible? Well, we are declaring, we're telling that as long as this we're trying to add an item that is related to product, is a derived class of product, let's go ahead and add it to our inventory, our list our generic list, right? So that's what we're able to do in order to get that behavior. Now, whenever I loop through, notice that I'm not trying to make item into an automobile or a book. I'm just making it into a product, because I know that if you are of type product, you are going to implement print one way or another. If you don't implement it yourself through override, then you're going to get this base implementation. So that's the kind of confidence that we can have in writing a statement like this, because we know that a product has a print method. So if I were to type item dot, I would see all of, item dot. Now we'd be able to see that there is, at a minimum, a product ID and a print method that we can rely on. So we can loop through and print. So here we go. We finally did it. We were able to get two different types to call the print method, two different types to be added to the same collection of objects, by making them inherit from a base class and then using a generic collection of type that base class product in order to treat them all equally. And as long as we're not using a specific form of it, we can get this polymorphic behavior. This is polymorphism. This is a simple example of it, but it is polymorphism nonetheless. Okay, this is great. But let's take a look at product.cs. What if we don't want to supply an implementation of for print in the base class? What if we want to require that any derived class must implement print, but we don't want to force a specific implementation? In other words, we don't want console.write in this class because it's not specific enough. If you're going to become part of a child of product, then you need to implement it, but I'm not going to tell you how to implement it. I'm not going to give you a backup plan, okay? So how do we do that? Well, the answer just might be abstract classes, and we're going to look at abstract classes in the next video. See you there. Thank you.